Welcome to qnawire.
Okay, in this problem we have a woman on an elevator. So here's our elevator. And the woman, she's holding a package. So a box here. Her mass is 60 kilograms, so the mass of the woman. And then the mass of the package is 9 kilograms. And we're told that she has the whole elevator has an acceleration of g over 4. So that's going to be 9.81 meters per second squared divided by 4, which is 2.45 meters per second squared. So it's accelerating upward at this rate. In the first part, we have the force that's accelerating them upwards, so the force of the elevator on the woman and the package. So they're calling this force R. And then we just have the weight, so that's going to be the weight of the woman and the package. We'll call that the total weight. And so the total mass here for part A is going to be 69 kilograms. That's just the woman and the package. So we, of course, know that the sum of the forces equals mass times acceleration. So in this first part, we have two forces. We have this force that's pulling the elevator up, that's acting on the woman and the box. So our system here is just the woman and the box. And on this system, we have this force R and then the weight of both of them, which is mg. So the sum of our forces here is R minus mg, so m total g, and that equals the total mass times the acceleration. And we just want to know what R is, so we can add mg to the other side. So it's going to be m total A plus m total g. So we can just pull the mass out here. We have A plus G. So then plugging in the values, we get 69 kilograms times 2.45 meters per second squared plus G, 9.81 meters per second squared. We already took the negative sign into account when we said negative mg, the force is pointing downward. So then plugging this into a calculator, we end up with about 846 newtons. The force pulling the woman and the package upward is 846 newtons. And in part B, we're basically doing the same thing, but just for the package. So in this case, we have L, so we're just calling the upward force on the package L, and then there's the weight of the package in the downward direction. L minus the weight of the package equals mass of the package times its acceleration. And its acceleration is the same. It's accelerating at the same rate as the elevator and the woman. So solving for L, then we get the mass of the package times A plus the weight of the package. So that's just the mass of the package times G. Again, pulling out the mass, we end up with 9 kilograms times 2.45 meters per second squared plus 9.81 meters per second squared. This is going to give us about 110 newtons for this lifting force on the package alone. And then they ask, what would happen if the elevator basically went into free fall and the cord was cut? What would happen to L and R? So in this case, so for this last question, L and R would go to 0. So in free fall, so with no other forces acting, in free fall, gravity is the only force. There is no lifting force on either the woman or the package. Those go to zero, and the only force acting is the weight, and that's pulling it downward.